So I'm gonna subdivide it into rectangles, take the area of each rectangle, add them together. I get the same thing. Well, don't need to do that for here because the height is always the same, okay? And we're gonna make sure that the rectangles have the same base every time. But when I get something like this, boy, look at the height, it changes. So I'm interested in this area under here, and I can make different rectangles. Let's say I want to make, well, over there we made 6 rectangles, so let's say we make 6 rectangles. I'm going to kind of try to estimate 6 rectangles here. Try to make it the same base. Well, there's 3.
Alright, why are you going slightly above?
Oh yeah, I'll explain that. Okay, so I'll try to find the area of each rectangle and add them together. That's gonna give me probably not the exact area, but since I know how to find the area of rectangles, base times height, it'll be pretty easy to figure out the area of each rectangle and then add them together. That'd be pretty easy. And if I make the base the same every time, that'd be pretty easy. It's just the height that's changing every time, right? That'd be pretty easy. So yeah, why did I go above and below on some of them? Well, because it's a curve. So where do I want to take the height to? Sometimes we take it, if I did this. Let's take the height being the right side of the triangle. So the height is going to be whatever the curve is at that value of x. And the height is going to be whatever that value and whatever that value. Since the rectangles have different heights on each end, right? So I have to pick the height. Do you want to use the right side, the left side? That's what we're looking at. Do you want to use the right side or left side? Well, if I use the right side here, you know, I'm not including some values. I'm not including that, I'm not including that. I'm overestimating here, overestimating here. Didn't get that piece, didn't get that piece. But I'm going to tell you, if you did the left side, you'd be missing something also. But that's what we're going to try to do. We're going to try to, because we know how to do rectangles, right? So we're going to find the area of a bunch of rectangles. We're going to make the base the same, because that'll be easy. The height will change, and the height will depend on the height of the curve at a particular value of x. That's where we're headed. So before we practice it, I'm just going to, that's what we're doing. We're going to need to find the area of something with curved sides. We'll pursue a similar idea for area as we did for tangent lines. Remember, we approximated the slope using secant lines, then taking the limit of these approximations. We were getting closer and closer. The secant lines were getting closer and closer to the tangent. So that's what the limit was. That's what we're going to do here. We're going to have rectangles, and if you looked at what I drew, doesn't it seem like the more rectangles I have, the less area I'm not including? Because I'll have, what if I had 20 rectangles all going up? Well, then I don't have as much empty space. But I still know it's only an approximation. So I'm going to be taking the limit of, what do I think they're approaching, okay? So this time we'll use the area by using we'll approximate the area by using rectangles and then take the limit of the areas of these rectangles when we add them all together. Especially as we create more and more and more rectangles until, how many rectangles do you think we're finally gonna have at the end? That could give us the best estimate. 100 rectangles? Wouldn't 1,000 be better than 100? 50? Oh, you're not gonna wanna do 50. What about an infinite number of rectangles? That's where we wanna go. Yeah, an infinite number of rectangles probably give me the best estimate. Okay, so I say happiest, well, okay, we'll do it together. Estimate the area under the parabola y equals x squared between 0 and 1. That'll look like that. In fact, I should probably make it bigger since we're gonna put some rectangles underneath. Between 0 and 1. And let's see, when x is 0, y is 0. When x is 1, y is 1. And it's a parabola, so it's gonna look like that. So I want that area under the curve. Starting, so it's contained in a square. If I just want to do one rectangle, that's going to be a big overestimate, though, right? Why don't I cut the square in two? Okay. We're going to use, whenever I add more rectangles, I want to make sure that it's equal width, and its height is going to be somewhere on the curve. So maybe I do 2 rectangles. Probably still an overestimate, right? Because I'm including this area, which isn't underneath it. But probably not as much, right? I don't have as much dead space with 2. What about 4? Probably, as you're thinking, that's probably gonna be even better. Let's see, this one, and then this one. And that's probably a better estimate. Still an overestimate, but I probably don't have as much of this space anymore. You can imagine, okay, well, let's change it to 10 rectangles. That's probably even better. 50, probably even better. 100, probably even better. Okay? And so I just said, let's start with the right side of each rectangle going up. So I'm gonna have this value, and this value, and this value. And because there's 4 rectangles, I need 4 x values in between 0 and 1. Well, we're gonna make them all equal length, so it's gonna be pretty easy to figure out what these x's are. So that'll be, what, 1/2? X will be 1/2. This one will be 1/4. This one will be 3/2. This one will be 4/2, which is 4. No, I did that one. Sorry. 1/4, yeah, sorry. 3/4. 1/4, 2/4, 3. Yeah. 3/4. And then 4/4 is 1. So those are the values of x I'm going to plug in. Plug into what? Plug it into the equation, because that'll tell me what the y value is, how high it is. So I'll have, hey, all the same base times height. How high is the height? Well, I'll plug in these x values into that, and it'll tell me how high that is right there, and right there, and right there, and right there. Cool. Probably see why we don't want to do it 100 times. We'd be plugging in 100. We'd have to divide my interval by 100 so that they'd all have the equal length, and then just go. If I was trying to figure it out between 0 and 1 with 100 rectangles, this would be, ooh, the first x would be 1/100, then 2/100, then 3/100, 400. Man, I'd have to plug it in 100 times. But that'd be a pretty darn good estimate. There probably wouldn't be a lot of dead space there. Okay. So you see what we're trying to do? theoretically what we're gonna try to do. Probably not with a whole bunch of huge number of so. Okay, so if we look up here, and again, this is on Canvas if we wanna go back and look at the notes. So, this would be my interval here. See, 1/4, 1/2, 3/4, and 1. So notice they all have the same base of 1/4. So 1/4 times what? It's the height that's changing. And I figured that out. I figured out base times height, plug that in, plug that in, plug that in, plug that in to the equation. Found out what the height was here, 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 and here. The base was still multiplied by 1/4. Add them together, I got this when I added them together. That was the right side area. Well, usually people tell me, well, then pick the left side. Okay, then I would be plugging in that, and then that, and then that, and then that. I would be plugging in those 4 values of x. And the base would still be 1/4, 1/4, 1/4, 1/4, but I'm gonna get different heights. And when I did that and added those 4 rectangles together, I did this, left side. And you know what I found out? On the left side, hey, it seems like I was missing some space under that curve because I was going from the left side. You can kind of visualize if I'm going from the left side, especially if this one's 0, right? And the next one is going this. Hey, I'm missing some areas. So that would be an underestimate. And here I included some area that I didn't need to include because I was using the right side. So I was using like this, and so I didn't need that space up there. That was an overestimate. So I know the actual area is somewhere between using the left side and using the right side. And if I use more rectangles, these numbers would probably get closer together. Are we okay with that? Okay. Now, it's not always gonna be the left side is an underestimate, the right side's an overestimate. It depends on what the graph is doing, whether it's concave up or concave down, as to whether your rectangles are above it or below it. But anyway, as the number of rectangles increases, both L and R become better and better approximation to what the actual area is. So ideally, we'd love a lot of rectangles. That would give me the very best estimate. Okay? Can we do the same for other curves? Absolutely. Okay? So, we just want to make sure the width of all of our rectangular strips are the same. And that's pretty easy to do. Let's say you want to find the interval between A and B of the area under the curve. Then take that width, B minus A, how wide is the whole interval, and divide it by the number of rectangles you want to do. N is the number of intervals or rectangles. Okay? And then make each one that size. Make them the same size. I'm going to show you why you want to make them the same size. Although I'm also going to show you, be careful. They don't always make them the same size. And then the little nice handy dandy little thing I'm going to show you won't work if they're not all the same size. But all the same size, change of x, how is your x changing? In the last one, it was changing by 1/4 every time. I was making up each one 1/4. The change of x is going to be the width of your base. So take the whole width and divide by how many rectangles you want. Make them all the same width. That's your base. We could say, move this up a little bit. This will be my base. all my bases will have the same meaning. So we'll do capital R, capital L to say whether I'm doing it from the right side or whether I'm doing it from the left side. And so notice what I'm doing each time. The change of x, which is your base, which won't change, that'll be the base of each rectangle. The height is what is changing. So you have to plug in the different values of x at that particular spot to get what the height of that rectangle is at each of those spots. And that's why you have to subdivide it to figure out which value of x am I going to be plugging in. And it depends on whether you're using the right side of the rectangle or the left side of the rectangle. Little n here means how many rectangles? R sub 4, let's do the right side using 4 rectangles. L sub 7, I don't know if you want to do an odd number, but if you do. L sub 7 is, let's use the left side of the rectangles, but let's have 7 intervals. Let's have 7 rectangles. Okay, so I could use the right side. I gotta figure out what the x values are. Or the left side, gotta figure out what the, if you're using the right side, the very last number of your interval will be the last x value. If you're using the left side, the very first value of your interval. So if your interval is going from A to B, B will be what you plug in, the height of the last one. And A will be what you plug in for x on the first one. But then I always get people that say, you know, left side, that's not perfect. Right side, that's not. Why don't we use the midpoint? That would really look good. Because if I'm using the midpoint between 1 and 1, and let's say I want to divide it into 4, I'd be kind of doing, oh, it's going to be fun. Trying to find the midpoint. Didn't quite do that.
Scared to ask Mr. He's like my second uncle, so
That might be better, right? I might not be so far off in my estimate if I use midpoint. So a lot of people say, hey, let's use the midpoint. The thing with the midpoint is you can't use one of the sides of the rectangle. You got to figure out what the midpoint is. Well, we could do that, right? Just add the two x values together and find the one in the middle. Add them together, find the one in the middle. And use that one to plug into your equation and see how high it is at the midpoint. How high is that rectangle at the midpoint? Okay, you could do that. We'd still be doing the same thing. You still want to make sure your bases are the same. Because you know what you can do? If there's no question, I'm going to show you what you can do if the bases are the same each time. If I haven't already shown you that. But if the bases are the same, what I can do is factor that out. And it would be this times the height using your first value of x, plus the height using your second value of x, plus dot, 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 the height using the last value of x. So you just plug in, if you got 4 values of x, plug in the 4 values of x, add that together, multiply by the base. Multiply by the base 1 time. Because this thing is common to all of them. So if you have the same width base, you just pull that width of base out, and you're just plugging in different values of x to get the different heights. Add them together and multiply. Okay? These are called Riemann sums. You will be responsible for doing Riemann sums on the AP exam. Don't worry, we're gonna do a lot of Riemann sums. Looks like Riemann sums. Riemann sums. So what this means, hey, we're gonna add up from 1 to however many rectangles we want, the height. So we're gonna plug in the different values of x. Remember what the sigma stands for? Did you all have that before? Recount. Sigma means just add up, starting with that number. Hey, start out with the first value of x, and the second value of x, and the third value of x. Add them all together, times dx, the change of x. Multiply by the change of x. That's what that's really telling us to do. And that will be the limit. Well, that's going to approximate what the limit is as the number of rectangles approaches infinity. The more rectangles I have, the better approximation. So it's a limit again, which by doing these Riemann sums, adding all the rectangles together, change of x. I can write it like this. Introduces a new symbol to us. Integral. The integral. The integral means, among other things, area under the curve. The area under the curve between this value of x and that value of x. The area under the curve of this function, dx, change of x, okay? The area between a and b of this function in terms of x. So that really takes the place of that change of x. If I had an infinite number of rectangles. So notice I say, hey, this is going to approximate this, but this is actually that if I had an infinite number of rectangles between A and B. Whatever this is going to be exactly what that is. Kind of sounds like the derivative, right? Whatever the limit was turned out to be the derivative. In this case, the limit of the area of all the rectangles is going to be the integral, the area under the curve. Okay. So that's what that means. We'll come back to integral. Well, you're going to see integral on some of the questions, but that's what it means. Oh, I had the dimensions, which it might be too. Let's see. What have I? Yeah, here's what I assigned here. On the College Board, and they're going to base it. I think one is from the left side, one is from the right side, one is one of these left side, right side. Okay. Hey, let's do some examples. Okay, we got 2 examples. Might as well do them. Let A be the area of the region that lies under the graph of f of x equals e to the negative x between 0 and 2. Does anybody know what that graph looks like? E to the negative x between 0 and 2.
Like the area
Yeah.
between those points of the function.
Right, but what does the graph look like?
Ah, no. The other side.
Well, you can see what it looks like. Or, does it matter?
No.
It doesn't matter. I don't know. I don't think it matters. Because you know what I'm going to do? I'm going to divide this interval, remember, change of x. We want 4 rectangles, and we want to use the right hand points. So the change of x is going to be 2 minus 1, or 0, right? I said between 0 and 2. So the entire width is 2, and I want to cut that up into 4 rectangles. So that means each one's going to be half the width. Okay, so that means it's 1/2, 1, 1.5, which is 3/2, 2. And I want to use the right side, so I want to use this one, and this one, and this one, and this one. I don't really care what the graph, because I'm going to plug it into the actual equation. And it's going to give me the area of these rectangles, whatever that graph looks like. Which means I can do it for any single graph. Okay, so the question was, using the right, and find an expression for the area as a limit, and then figure out what it might be. Okay, so find an expression for the area equals the limit as x approaches infinity of e to the minus x, and we're using right endpoints. So we're using right Riemann sums. Oops, I said equal. I know this is going to be an approximation. It's going to be an approximation. But since we did each of the bases the same width, why don't I pull that out? Right? I'll just pull that out. Well, the change of x is going to be 1/2. Each rectangle is going to be 1/2 wide, 1/2, 1/2, 1/2, times its height.
But are they asking to do it that way?
Yeah.
Okay, that's
Yeah. That's estimate. Estimate. Yeah. Christian's wanting to jump in. So I know that's gonna be 1/2. 1/2 times this height, 1/2 times the next height, 1/2 times the next height. But what's the height, all 4 heights? Well, the first height is gonna be e to the minus 1/2. That's the first, where x is 1/2. Plus e to the minus 1, plus e to the minus 3/2, plus e to the minus, the last one is 2. There's an expression. And so we plug that in our calculator. I don't see how you cannot do that with a calculator. But, or how you can do it with no calculator. Is it okay if I put the final answer? I kind of skipped to the chase. Ooh, did I put the final answer? I don't think I did put the final answer. What? Somebody want to do that real quick, see what the final answer is? E to the 1/2 plus e to the negative 1 plus e to the negative 3/2 plus e to the negative 2. Get that answer and then multiply by 0.5. I just set everything up. .667, something like that. Oh, 6664. I don't like looking at 666, so I'm gonna put 4. Okay, so that's what, and that would be square units, unit squared. Now, is that actually the area? No, the area equals the limit, and the limit is about this. So I'm gonna say the area is about that. Is it an overestimate or an underestimate? I don't know, I'd have to draw the actual curve and see. But I know it's not exactly the area. And I only use 4 rectangles. That's probably around there, right? Question? Could I do the same thing with left side? You betcha. What would be better than using 4 rectangles on the right side? Look at the next part of the question.
Using 4 sub-intervals, usually it's okay.
Estimate the area by taking the sample points to be midpoints. Oh, okay. Well, let's see. The Riemann sum from the right using 4 rectangles gave us 0.6664 units squared. Okay, let's try the midpoint. So let's see, we're gonna use the midpoint estimate for the area. Midpoint, using 4 midpoints. I can use this same triangle. I need that point there, that point there, that point there, that point there. Because that's where I'm hoping the top of the rectangle is gonna be. I'm not changing the rectangle. Should I change it? Maybe I should. Maybe I should change the rectangle. And the midpoint of this one. Okay, now I'm going up, now the rectangle, the top of the rectangle is at the midpoint of each. Well, what's the width of each rectangle?
1/4. No, not 1. Yeah.
1, 2, 3, 4 rectangles. Nothing changed, the width is still the same. 1/2. 1/2. 1/2 times that height, 1/2 times that height, 1/2 times that height, let's factor it out. What's gonna be the height of the first one? Well, what are my x values now that I'm gonna be plugging in? The midpoints. This was a half, so divide that. That's gonna be a 1/4. That's a half. That's 3/4. That's 1, 1.5. Is that 5/4? 1/2. Is that 7/4? There's what I'm plugging in this time. So, the equation was e to the negative x, is that right? Negative 1/4? Plus e to the negative 3/4? Plus e to the negative 5/4? Plus e to the negative 7/4? You can use decimals if you want to. I mean, you could say, hey, that's 0.25, 0.75, 1.25, 1.75. That's fine. Okay, add all that together, multiply by the base, the width of each rectangle. I got this.
16.
Square units.
Just like how I got this.
The area is about that. And what I know is that's probably a little bit better estimate than the right side was. Probably a little bit better estimate than the left side was. You know what would be even a better estimate? I mean, midpoint was probably better than right and left. Although I will tell you, AP loves to ask you either from the right or the left. More rectangles. More rectangles would have been even better. What if I did 10 of them? What if I did 10 rectangles? Yeah, what's the change? What's the width of each rectangle now? I'm still going from 0 to 2. And I'm dividing by 10. So that means each width is gonna be 2/10 or 1/5. Well, the width isn't gonna change of each rectangle, but the x values are gonna change. And if each width is 1/5, and I'm going between 1 and 2, I'm gonna have a whole bunch more. But what is the first? This will be confusing if I have the rectangles up there. Now I got 10 rectangles. We don't know what this is. I want 10 rectangles, so they're gonna be 5 rectangles here and 5 rectangles there. 10 rectangles across the whole thing. Each with a width of 1/5, 1/5, 1/5, 1/5, 1/5. What's the midpoint of the first one? What's halfway between 0 and 1/5?
110.
110. Which, hey, let's do one with decimals, okay? So negative 0.1 plus e to the negative, and then what's gonna be the next midpoint?
0.3.
Yeah, it's gonna be 1/5 away from that, which is, we're doing decimals at 0.2. So add 0.2 to that, negative 0.3 plus e to the negative, add another width, 0.5. That's why we want the same width every time. Plus e to the negative 0.7. We're gonna have to do this 10 times, right? Yeah. If they ask you to do this 10 times, let me know, because I will be greatly surprised. Plus, you can just do this. All the way up to e to the negative. Hey, what would be the last one? That'd be the midpoint of the last one. Right, that'd be the midpoint of the last one. So, boy, this is fun. On your calculator. 1/2 times all of that. I did that. I did all of that, then I multiplied by 1/2. You know what I got? It didn't change by much, but I know that that's a better estimate than that one is. Right? So I'm starting to kind of see what the limit's gonna be. If I did 50, I'm probably not adding much more. See, it's kind of flattening out here, what the limit's gonna be. But still, I'm approximating. To me, that's a good place to stop. This is very cumbersome. Probably the most cumbersome thing we're going to do is Riemann sums. So to answer your question, Christian, yes, they want you to do Riemann sums. A lot of times they will just set it up like some of your multiple choice. questions, I just said, hey, this is the way it would look. And sometimes they want you to do it. And the most I've ever seen them make you do is 6. But that's still, and you're probably gonna have a calculator too. It takes it. But I've never seen them ask you to do 10, or God forbid, anything more than 10. 'Cause hey, if you can do 4 or 6, they know you could do 10 or 20 if you had the time. Right? It'd be the same thing. You just subdivide. Anyway, I do want you to maybe try one before tomorrow.
Yes.
At least try one. Because I'm gonna show you how we can use this in another situation.
Yes, I will.